Hello, today's lesson will be on finding determinants of a matrix. Now remember, matrices rather come in all different sizes and dimensions. So here I already have 6 matrices up top. Matrix A, and we name a matrix rows by columns. We call it R by C for short. So we name matrix A just by calling it a 1 by 3 matrix. It has 1 row and 3 columns. So 1 will be in column 1, 3 will be in column 2, and then 5 will be in column 3. B is a 3 by 3 matrix. And C is a 2 by 2 matrix. It has 2 rows and 2 columns. So is D. E has 3 rows. 1 and 7 is the first row. 2 and 3 is the second row. 0 and 8 is the third row. And then column 1 is 1, 2, 0. Column 2 is 7, 3, and 8. Okay. So therefore it is a 3 by 2. E is a 3 by 2 matrix. And F is a 3 by 3 matrix. So one of the things that we want to recognize is that, hey, matrices are enclosed in square brackets. When you're asked to find a determinant, so for example, at times they may just ask you to find the DET of A, or another way of asking you to find a determinant, they may just put A in vertical bars, very similar to what you may see in an absolute value bars. So if you see vertical bars and they're asking you to find the determinant of matrix A. Now in this case, since matrix A is a 1 by 3 matrix, it's not possible. One of the very things that you have to remember is, in order to find the determinant of a matrix, it must be a square matrix. A square matrix has the same number of rows and columns. So, number 1, to find the determinant of A, it's not possible. Why? Because matrix A, is a 1 by 3 matrix. It's not a square matrix. What do we mean by a square matrix? Again, the same number of rows, the R by C, must be the same. So we call it N by N. So for example, 2 by 2, a 3 by 3, and so forth. So that leads us to question 2. If I ask you to find a determinant of matrix C, you can do it. So let's just say, hey, matrix C is 5, 3, 4, and 2. So to find a determinant, all we have to do, and I'll color code it, is take this diagonal, 5 times 2. All right? And then we're going to subtract, so we're going to multiply the elements in that diagonal to figure out its product. And then we're going to subtract and do the same exact thing for the other diagonal. So in this case, I'll color code it blue, 3 times 4. So in this case, the determinant of this particular matrix is the difference of that first diagonal, which in this case is 10, minus the second diagonal, which is 12. So the determinant of C is just negative 2. Okay? So you can find the determinant of that matrix C because it was a 2 by 2 matrix and that determinant was 2. Let's take a look at D. If I told you find the determinant of D. All right? So in that case, when we find the determinant of D, you have 8, 4 in the first row, 6 and 3 in the second row. Okay, so in this case, again, I'll color code it to help us. You take the 8 and the 3, that diagonal. All right, The product would obviously be 24. And then you're going to subtract it from the second diagonal. All right, in this case, it's 4 times 6. So that particular diagonal produces a product of 24 as well. So in this case, the determinant of matrix D is equal to 0. Okay. If we were asked to find the determinant of matrix E, let's make this a little smaller, give ourselves some little more room. So question 4, if I said, hey, find the determinant of E, you take a look at it, you identify the dimensions of matrix E is a 3 by 2, you would say not possible. And the reason why is not a square matrix. Okay. All right. So in that case, there's no solution. Okay. So now if we were to take a look at a problem like number 5, and I asked you to find the determinant of a 3 by 3 matrix. Okay. All right. So in this case, before we jump into it, we ask ourselves, can we find the determinant of a 3 by 3 matrix? You would say yes. It's a square matrix, same number of rows as columns. So before I get into it, let's just say, hey, because a 3 by 3 matrix, to define the determinant of it, and let's just say, hey, I give you this particular matrix. I'm going to use letters A, B, C, D, E, F, G, H, I. Okay. What we're asked to do, one way of solving, finding the determinant of a 3 by 3 matrix is to rewrite the first 2 columns. So I'm going to write A, D, G, B, E, H, just like that. Okay. From there, I'm going to then go ahead and do a diagonal. But watch this. I'm going to color code them. I'm going to multiply. I'm going to start in this with element A, with element A is in what we call the first row and the first column. So it's going to go A, E, and I. And what I'm going to do is I'm going to multiply all of the elements in that first diagonal. So it's going to be the product, A times E times I. So then I'm going to do that for the other matrices as well. I'm going to go ahead and, the other diagonal as well, right next to it. I'm going to do the same thing for the next diagonal, BFH. B times F times G. Then I'm going to go CDH, CDH. So I'm multiplying. That first diagonal is going to produce a product. That second diagonal, in this case, B, F, and G, is going to produce another product. And then C, D, and H, that's going to produce another product. So then from there, it's going to give me a nice, and I add all those products up, and it's going to give me a nice sum of those first 3 diagonals. Now, I'm going to subtract. Now it's going to be, so it's nice to kind of group that one together. Okay. So now this second set we're going to put in blue. Okay, and we're going to do the same exact thing, but we're going to start on the opposite. So we're going to start at the opposite end. We're going to start with B right here, and we're going to make a diagonal, BDI. So B times D times I. We're going to do the same exact thing with A, F, and H. And then we're going to do the same exact thing with this last one, CEG. Okay? And we add all those up. And the difference of those two would be the determinant for a 3 by 3 matrix. So again, you rewrite the first 2 columns, and then you just take the red diagonals, multiplying each of the elements along that diagonal. And then once we figure out that product of each diagonal, we add them all together. and subtract from the second set. So with matrix B, I'm going to rewrite it. 6, 2, 0, 1, 3, 5, negative 1, 4, and 8. Rewrite the first two columns again. 6, 1, and negative 1. 2, 3, and 4. We'll use color to help us. All right, so along this first one, it's going to be 6 times 3 times 8. So 6 times 3 times 8. 18 times 8, I believe, is 144. Okay. So then we go ahead and do the one right next to it. 2 times 5 times negative 1. 2 times 5 times negative 1. That's going to give us a negative 10. 0 times 1 times 4. That's going to give us 0. So when it's all said and done, this first, the first diagonal gives us a product of 144. The second one gives us a product of negative 10. The third one gives us a product of 0. When we add all these sums, all right, when we add all these products together, rather, the sum is 134. Now we're going to subtract. Now we got a second set, and I'll put those in blue. Start with 2 in the other corner. 2 times 1 times 8. So I'm going to put a big bracket. Then it's going to be 2 times 1 times 8. That would give us 16. Then it's going to be 4 times 5 times 6. That's going to give us 20 times 6, 120. Negative 1 times 3 times 0. It's going to give us 0. So you're going to love it when it's a 0 because that's an easier computation. So 16 plus 120 gives us 136. So now we are able to find a determinant of B. And that will give us, of this 3 by 3 matrix, negative 2. So finding a determinant of a 3 by 3 is a little bit more work than a 2 by 2. But still, by being careful and being organized, you'll be able to have good success. Hope you enjoyed it. Bye-bye.